Today is August 27th, 2007. Brian Keegan is interviewing Professor Mildred Dresselhaus for the MIT 150 Oral History Project. Thank you for taking the time today to meet with us today, Professor.
My pleasure.
Now, this project aims to capture aspects and perspectives of members of the MIT community who've participated throughout MIT's history, and it's on the occasion of MIT's 150th that we want to start to look back as much as to look forward.
So when's the 150th?
150th will be in 2011.
2011.
April of 2011.
And you're hoping to get this, some aspect, some progress with it.
Hopefully. We
I mean, you probably won't do everything that you want to, but...
Never can.
But, yeah, it's sort of like the 250th anniversary of Mozart.
Sure. Yeah.
They were rushing to get it all done by 2006. I remember somebody talking to me about that.
Sure. Now, we're going to skip ahead a little bit. Maybe we'll come back to your biography later, but maybe you can tell me, after you left Cornell in your postdoc, you were offered a job to come to MIT. What had you heard about MIT before? Tell me about the Project Whirlwind that you had been offered initially before you left for Cavendish.
Oh, yeah. Well, the Project Whirlwind, at the time I was offered that job, or that was RA in the math department, at that time it seemed like an exciting opportunity, but I didn't really know too much about, I didn't really know the history of these various computer projects that they had. They had a previous project at the University of Pennsylvania that happened during the war years, and that had a big impact on computation during the war years, and brought computers into some level of contributing to computations for trajectories for missiles and so forth. But not that much, I guess, because it wasn't very widely used. It's not, I mean, at that time, I guess people had already some idea of what computers might do, but only a very small inkling about it. So I had a chance to be involved in one of the early projects, and it would have been a totally different career had I done that. But I didn't come, not because I wasn't interested in it, but I was interested in the other opportunity more. So it was a choice between two good things. You know, in lifetime, you seldom have two really good things coming up all at once, and you have to make a decision. So my decision turned out okay for me. I don't know. I have no idea what the other decision would have been. You know, it's sort of a useless issue. But looking back now on the history of computer science, that would have been a very interesting thing to be involved with.
Now, while you were at Cavendish or Radcliffe or University of Chicago, what awareness did you have of MIT or the research that was going on there, either during the war?
You know, the war years, research formed a body of information that we use as textbooks. You know, the radiation series was a terrific series on electromagnetic theory and many other things. So it was a constant reference source. I did a thesis in microwave properties of superconductors, and that was a main source of information of microwave properties of materials and cavities and whatnot. So, yeah, sure, MIT had a huge reputation, and it was, for me, it was kind of serendipity that I had a chance to join the system. And the reason I joined the system had to do with the fact that MIT didn't have a discriminatory policy against two members of the same family of joining organization. I don't know exactly about the history of that, how many people before me benefited from that aspect, but it certainly made a difference. So that's why we came to MIT. It really had nothing to do with so much the reputation, except we joined a very good laboratory And we had exceptional jobs in that in the history of science, when you look back nowadays, we have no jobs that were like the jobs that we were offered at MIT, the Lincoln Lab. Insofar as our obligation was to do basic research and to help people at the lab that needed to know something about solid-state physics. So that, what could be better than that? You know, it was kind of an open-ended job. Those kinds of jobs don't exist today.
Now you mentioned that the nepotism rules played a big aspect in your decision for Gene and you to come to MIT. Who recruited you?
Ben Lax.
And was there a research project that he wanted you to work on in particular?
No, basically, he knew both of us individually for our previous work, and he wanted us to work on things that we knew something about. But my field was, I had worked on superconductivity, and he had formed an opinion himself that that field was finished, that once BCS theory came along and explained so many things. It didn't explain my thesis, but explained many other things. And so he really didn't want me to work on that, but most anything else. So that turned out to be a great opportunity. You could look at a decision like that, being hired to do something other than what you knew about, as a negative. But this turned out to be a big positive in my career because I learned another field. And I had, from my graduate school experience, I had the background to work in many fields of physics. So this worked out really well.
Now you worked in the National Magnet Lab while you were when you came to the MIT Cambridge campus, or you were out at Lincoln Lab?
I was sort of half-time at each place. The Magnet Lab, when I was hired at Lincoln Lab, was in Building 4 of the main campus, right in the basement. And at that time, it was just a laboratory of a professor. It wasn't a national facility or anything, but they had some ideas to make it into a facility. And I was one of the very few people, it was a handful of people only that worked with the high magnetic field facility at that time. It was not a big enterprise like it later became. So I was one of the originals, so to speak, or close to the originals.
What was the atmosphere like when this was the mid-'60s, right? What was the atmosphere like there? Who were you working with when you were at the lab?
Well, the atmosphere changed quite a lot during the 60s. When I joined the lab in the 60s, everything was open and physics was expanding greatly. That was Sputnik time. And there was a big expansion in science nationwide. And I was part of that, and my hiring at Lincoln was part of that movement. But in 1964, there was a kind of a big change that took place. There was what was called the Mansfield Amendment that said that funding of defense-related research should be related to defense. Well, broadly speaking, everything that we did was related to defense, so that was not necessarily a big restriction, but along with the Mansfield Amendment, there was a part about it that was accountability, that the different people working on projects had to account for their time. Now, before that, just the output was sufficient. And there was plenty of output coming from the lab, coming from myself and all the other people that I associated with. So this was never an issue for us. But there was now an accountability of what you did between hour 9 and 10 or something like that. So, and we've been living with something like this ever since. In some ways it's good because people should be accountable for what they do. But in some ways it's bad because it sort of stifles creativity. You can't be totally creative if you account for everything that you're doing. You need some time to just think.
Now, who are some of the notable or memorable people that you met during this early time you came to MIT, whether at the Magnet Lab or Lincoln?
Yeah, well, there was Ben Lax who hired me, and he was a great scientist, and he and Jean Dresselhaus were involved in the very beginning experiments of cyclotron resonance, so that's how we knew Jean.
Okay.
And so he was very happy to have him work on anything connected with that sort of area. And I sort of got moving into the optical aspects of that, which Ben Lax was interested in. So I learned something that he wanted me to learn, but I wanted to learn it too. So shortly after, I diverted. So the first 6 or 9 months I was with him on this project, I was doing semiconductors, just straight semiconductors like a lot of other people. And then I decided I wanted to do something was a little bit more my own, and I went into doing semi-metals. And that was something totally different, or, well, he had made a bridge with bismuth, but that was just a piece of the action, and I moved on to carbon-based materials from there, which he thought was too complicated. But, you know, he gave me the freedom. He had some confidence in people, and he gave us the freedom, as long as I worked on things that he wanted also, which I did. And he was happy, and I was happy. So, of course, when we look back at what was done, the carbon-related work turned out to be the important work, as history will tell us. But one has to do things that your colleagues need, you know, so that's part of it. So I didn't mind doing that, and
now,
I learned new things from doing it.
Now, when you came out from your postdoctoral work and you came here to MIT, you mentioned that was it hard to find a niche? In terms of applied physics, everything in physics was high energy physics, and electrical engineering was just circuits. How did you find this area?
Actually, that when I was out at Lincoln Lab, that was interdisciplinary research. So we had people in all fields working together. And that was very much like the industrial labs in the U.S., generally Bell Labs, GE at that time was a great lab too, and Westinghouse and so forth. They all had similar approaches, and Lincoln was among them. It was a great laboratory at that time when Ben Lax was there. So, he was there for about half of my stay at Lincoln Lab. And then after he left to become an MIT professor, the atmosphere changed. It changed for two reasons. I think the Mansfield Amendment was part of it, that people had to be a lot more accountable. So it became counting beans, bean counting exercise. And so, you know, many of us didn't fare as well under that atmosphere. But for the most part, the research didn't change so much. It was just the rules that got to us. It was particularly bad for the women. There were 2 women out of all the men. And this affected us because we had young children, the 2 of us. So
this was at Lincoln Labs?
At Lincoln Labs,
okay.
Yeah, Laura Roth and myself. And so we both eventually left because of these restrictions.
So tell me about this. You transitioned from being a researcher out at Lincoln to joining the faculty here on the Cambridge campus in 1967. Tell me about
the transition.
Sure.
The transition, as far as the daily work, hardly changed. Because when I was a researcher at Lincoln Lab, I actually supervised some graduate students on campus. On campus, there were graduate students, and graduate students were always looking for research topics. And for a couple of cases, the individuals sought me out. So I was actually working with some students before I became a faculty member. But when I became a faculty member, I had more students, and then I was responsible for lectures, whereas when I was just a person at Lincoln Lab, I gave guest lectures. So that was the difference. But it didn't, the mode of work didn't change that much. It was a bit of a continuum. So I didn't feel, the biggest thing that I felt was the freedom and time. I didn't have to account for the time, and it was just getting lots of things done. As a faculty member, you know you have things to get done, and nobody's telling you what time you do it. And that worked much better for me than the system at Lincoln.
Well, who recruited or encouraged you to come join the faculty or made the appointment to the engineer or the electrical engineering rather than physics?
Okay, yeah, that's an interesting point. There were several reasons. For one thing, I was recruited by electrical engineering, and recruited is really the wrong word. I was looking for a place that I could spend a little time to do research without the time clock, without the accountability aspect, because getting to the lab at 8 o'clock turned out to be really difficult for me. So the Rockefeller family had this fellowship that they had started about a year before I had it. I was the second holder of that fellowship. And George Pratt, who had migrated from Lincoln Lab to MIT just before that, but still spent some time at Lincoln Lab, knew of my situation, and he put my name forward for this fellowship, and lo and behold, I received it. So that changed my career, because I, of course, accepted it. And that led to faculty appointment. I was here a very short time, and they folks here realized that I made a contribution to their, I would make a contribution to their program, because they were looking for somebody who could teach the students physics from an engineering point of view. So having worked at Lincoln Lab for 7 years, I apparently had some background that way, so I was hired to do that. But everything else was pretty much the same. The research didn't change very much, and what I was doing was at the interface between electrical engineering and physics anyhow, and later I got an appointment in the physics department. But in the early days, when I joined the MIT faculty, the physics department had very, very small commitment to condensed matter. It was almost all high energy physics. So, and the electrical engineering department needed people in this area because materials were very important to devices. So it made sense that I joined the electrical engineering department, and it was a good choice for me at that time and continues to the present, because I have a natural place in that department. But also a natural place in physics, because physics later developed a condensed matter program that is quite strong, and so I fit into that one as well.
Now, what were your initial impressions when you came to campus in a full-time? You were part-time before, but tell me about what the student body was like when you saw. I mean, in the mid to late 60s, there's an increasing number of women on campus. Tell me about the kind of advising and teaching roles you took on.
Right. Well, when I came, there were very few women, actually. There were only 4% women. It wasn't so many, and many of the classes I taught were all male. So that is, MIT had a small number of women, and electrical engineering had smaller than average, so it was really a small number. And because my fellowship that brought me here had something to do with a scholarship of women in science, one of the planks of the Rockefeller family endowment for that fellowship was to promote scholarship of women in science and engineering. So I felt that with that I should do something along those lines. So
now, was that considered a radical notion at that time? That
no, it wasn't. It wasn't radical at all.
Okay.
I think it was pretty well accepted. I wasn't a radical, and
right.
I didn't. I was doing my job really, because we had a talent pool. We had women here already, and they were having a hard time because there were so few. And it was believed at that time that the number of admitting women was somewhat risky because they weren't doing well. But upon looking at the situation, I felt that it wasn't the women, but it was the environment that they were in that contributed to their subcritical performance. So what happened was two things. I was involved with those, but these were welcomed by the faculty, actually. These were not controversial. They had different standards for women, admitting women and men. And I didn't know that, but I found out about this when they asked me to be on the committee to admit students. So, and they had me doing women students only because the criteria were different. But I looked at the admission of all students, and I saw that this was really quite different. And so the first thing that we did was we had equal admission that would be on the same criteria, academic criteria. And that fact increased the women by about a factor of 2, just overnight.
Now, what were those criteria that were
it
different?
Was where the cutoff would be on the SAT, et cetera, component, and the individual assessment. Those were the 2 criteria. They have interviews and personal characteristics, and then they have performance on exams. So those are the 2 main topics that enter into the evaluation, and for each of them they had different criteria at that time. And it's some of it which was subjective and some of it which was quantitative. But it was under the assumption that women weren't performing that well, so, or many of them weren't. So if they had equal admission criteria, then the women would perform worse even than they were at that time. But after discussing this among the few women faculty we had at MIT, we came to the conclusion that if we had larger numbers, they would do better. And that worked out to be correct. So,
now tell me something about the other women faculty who were here on campus. There was Sheila Widnow, Emily Wick, Laura Roth. What kind of relationship
Laura
did you
Roth
have?
wasn't a faculty member
Okay.
here. She was at Tufts.
All right.
She got a position at Tufts. Yeah, there was Emily Wick in nutrition. We had a nutrition department then. It became some applied biology later. But, and we had Sheila. She was a very junior faculty member at that time. And there wasn't much else in the School of Science or Engineering. I think Sheila was myself, we were the only ones, and I was tenured and she was untenured. That was kind of what it was. But
that was the extent of the women faculty that you knew it when you joined?
Well, we knew all of them.
Okay.
Because there was a woman in philosophy, Thompson.
Okay.
Who and she had gone to high school with me, so I knew her from a long time back. Yeah, it was a handful. I don't know, maybe 6 or 8. It was a very small number at that time. We were.
Now, would you have meetings, or, how well did you know each other?
Yeah, we got together for lunch over at Ashdown House, every month or something like that, and we would talk. And we decided we should do something to help the young ones coming along, mostly. And so because when Wiesner came in, he had the idea of appointing more women faculty, and so we took upon us to mentor them and try to, because they were in all kinds of departments that had no women. They were the first ones, and some of the men felt uncomfortable in telling them what they should be doing. So
now the women that you were mentoring or assisting, both at the undergraduate, were there women at the graduate level?
Oh, these are the students.
All right.
Yeah, yeah.
Now McCormick Hall had just opened up. It was an all-women's dormitory in the early 60s. Now, did you spend a lot of time working with the women from there, or?
I didn't spend, none of us spent a lot of time because we were all working on our own careers, but we spent some time.
Okay.
I mean, and Emily Wick was the one that spent the most time because she was Dean of Students, women's students, until about 1970. And then when there was a change of the guard, I forgot, there was some changes, and they had all the students under one dean. But the advising program for women students that Emily Wick had instituted had sort of crumbled at that point, and so the rest of us figured out how we could reconstitute some kind of substitute form. So that's kind of how we got involved with it. I'm sure Sheila must have said something about that as well, because she was involved with that, and I was involved also. And we started this course, What is Engineering, that had some impact, especially on women and minority students.
Tell me about that course.
Yeah, well, I had the idea that when the numbers of women students started to increase, the women were enrolling in different departments than the male distribution. And so we were concerned about that because of implications on faculty hires and all of that. If, thinking forward that there may be even more women than 10% maybe, which is what we had in, say, the early 70s, which of course happened. And so we instituted this course in the very early 1970s, like 1972. And the objective was to introduce students to other topics that they might be thinking of for majoring. So this was aimed at freshmen to broaden their insights, and so we had very interesting people from the engineering school, and then we did some of the classes ourselves, and some with interesting, just like you're interviewing people of interest. We did something like that, and it was very successful. We started, our original idea was we'd have sort of a dozen people that would be kind of like one of the seminar programs, and a semester the numbers increased to 100, and so we started running it not once a year but every semester, and then we took turns in taking the class, because we did this in addition to the other teaching assignments we had in our own departments. But it was a successful experiment, and then it was taken over after, I don't know, about 3-4 years that we did it, the two of us, by male faculty, and it became something. It had a different character later on, but it was still a good introductory course for expanding the horizons of students.
What was your reaction to being tenured in 1968? What impact did that have on you had a young family at the time, and your research obligations? Was that something you were hoping for? Because you were tenured only after a year since you joined faculty.
No, I was tenured when I joined.
Okay.
My appointment was with, I was a full professor when I was appointed. So it wasn't an issue, and I never asked about it. It wasn't, when they made the appointment, I don't remember any discussions about the level. We didn't discuss conditions particularly, and I was around. I just made a transition. It sounds very odd to you, but I didn't have anybody that alerted me to the idea that this was a big issue. So I didn't know it was a big issue, and it wasn't a big issue for me.
Being tenured.
Right, right.
Did it change the research? I mean, so if it wasn't a big issue, it didn't change your research goals? Or
it had no impact on much what I was doing. I just kind of continued. In fact, for the first 5 years I was a professor at MIT, I still kept up some of my Lincoln duties because I was running their seminar and whatever. I had involvement with various researchers there, so I would spend time between the two places, you know, like a day a week or something. But I think they paid some significant fraction of my salary for the transition period.
Now, you were named Associate Department Head for Electrical Engineering in 1972. Tell me about...
When that happened, that was a transition because that gave me many more duties on campus, and I found that I couldn't do those duties plus Lincoln. So Lincoln left at that time, and by that time Lincoln had already changed quite considerably from the time that 1967, when I came down to campus. So it made sense to focus on campus activities. And in fact, my husband came down to campus in 1977 when I became a lab director, because then I had additional duties also that were more than I could handle myself, because I had a very large research group by that time. So, and he wasn't very happy at Lincoln anymore, because it had the emphasis on basic research had changed quite considerably, and he wasn't all that happy with what he was doing. So he was happy to come down on campus.
You're also director of the material science.
That's what I'm talking about. That's 1977.
Right.
Right. So I was with Lou Smullen for the end of his term as department head. And then when he finished his term as department head, there was a new group that came in, and that was Davenport. And at that point, he had his own associate department head. See, when I was there, we had only one department. It was called electrical engineering. And computer science was born during my time. And then when I was finished, then we had two very distinct associate heads. When I was there, we did have two associate heads because the department was so huge and the number of students was so large that it was too much for one person. So that's the way that went. And so then in 1974, when that was finished, I went back to just being ordinary professor and doing my thing. But my life changed at that time through an external event. I was elected to the National Academy of Engineering in 1974. And along with that came a bunch of different jobs that they gave me to do. So it wasn't, after I was finished with my term as associate department head, I had other duties. So I was heading up the Bureau of Standards evaluation process. That was one of the jobs that I got from the Academy. So that was quite a big job because the Bureau of Standards is bigger than Lincoln Labs, and a very large number of employees. And the laboratory was divided into different divisions, all of which were evaluated, and I was in charge of the whole evaluation process. So I learned a lot of things about my appreciation of applications in industry and how industry and research interacted. It was all metrology. I learned all kinds of things.
Maybe we can return a little bit back to when you were associate department head for EE. Now, this was kind of a heady time for computer science in the late 60s and early 70s. Can you tell me something about how, was it just rumblings or whispers about the AI lab and the Laboratory of Computer Science, the work that they were doing, or was it occupying a large part of the faculty's research interests?
The birth of, when I started in 1972, there were it was rumblings, but it wasn't a big thing yet. And, but in the period of 1972 to 74, you could say that computer science was born. And there was emphasis on trying to think of what a curriculum might be and how the organization might be. And there were serious thoughts about keeping it within electrical engineering, because keeping the departments, the pieces together, but having it as two components of the same department. It turned out in the end, probably, that this was a wise decision. And I say this because other departments which split, like Berkeley, different places, they brought their departments together again later on. So, and there are many places that have ECE, so electrical and computer engineering, which is sort of like what we have, electrical engineering, computer science. So the model that we set up was actually followed by other places. But the resources for creating another department came out of EE. So these were kind of difficult times for EE in some kind of way, because they had to do some belt tightening to make CS happen. But that seemed like the right thing to do to us. And so that's what we focused on. And you know, as we look back, it was the right thing to do.
How much did you interact? There's so many kind of mythological or strong personalities associated with EECS, between Hal Abelson or Marvin Minsky. There's all these people who were kind of making a name for themselves at MIT during the early 70s. How well did you get to know them?
Oh, I knew them all. Yeah, well, the two that you mentioned were in CS, so Bob Fano was their boss because he was my counterpart in CS side. But yeah, I got to know all these people. And our policy was to promote the careers of everybody that was in the department. And we put up with lots of people that had independent personality, shall we say. But the idea is to make it all work, make them happy, but make the whole greater than the sum of the parts. You don't want to squelch people, because that makes them not happy and not so productive. And there's enough room in this place to put up with some difficult personalities, and just have to keep them a little bit reined in so that other people are protected. That's kind of the way to do it. Oh, Marvin Minsky was a great contributor.
Now, when you became director...
We had Letvin also, didn't we?
Right.
Yeah, he was also part of it, you know. He was a special personality.
Now, when you became director of the Center for Material Science in '77, was that, for you, did you enjoy the kind of administrative responsibilities that you had, or was it something about the research aspect rather than the kind of academic?
Actually, I felt that running the Center of Material Science and Engineering was a better assignment for me than being associate department head. Associate department head had too many personality problems associated with, you know, people issues. And running a lab had more research issues. So I had a big challenge when I took over this, because we were about to lose our NSF block grant. We were in big trouble.
We being MIT?
Yeah,
or?
MIT.
Okay.
And I was brought in to try to save it and bring things back, which I managed to do. So that was my job, which I executed.
How did the crisis precipitate, or how did you resolve it? Or maybe you can go into that.
Well, the NSF was unhappy with our program, basically, and we got some poor reviews from reviewers, you know, that these labs get reviewed. And so we were put on a short string for contemplated termination. Well, I guess MIT wasn't too happy about that because these laboratories served a very important purpose in providing central facilities for the whole institute. And so it wasn't only the people that got funding to do research, but the facilities that supplied that were very important. So I had to figure out a way to keep MIT people happy and also keep the NSF happy, which was done. And we all got together, and one thing that I did is I opened up the administration of the center, involved a lot of young people, and I put a big effort on training future leaders for the center, because I felt that the natural term was dedicated, was kind of influenced by the length of our contract with the NSF, which was a 3-year cycle. So I signed up for 2 terms, but I didn't make that widely known. I just the dean knew that, and the provost. And I kept to that. But I didn't plan on doing this as a lifetime engagement. So my idea was to build up the center, get it in good, healthy form, develop new talent that could be used for other administrative jobs. See, we had a big problem actually at that time, that during the war years, lots of people were trained and became good at running things. And then they were running things, and the young people didn't get the experience because the other guys were running things. So I recognized that this was an issue, so I put an emphasis into training people. And those people have gone on to do many things at MIT. So it was a good,
so you finished up your post there in '83, and you were also named to the physics faculty in '83.
Yeah, well, what happened with the end of my term was a little more complex than what you said. What actually happened was in 1982, or the fall of '81, I was elected to the American Physical Society to become president. The presidency was assumed in '84, but then I had a couple of years that first, I don't know, you have names for it, vice president-elect, vice president, and so forth. Okay, you have different stages of this. But I became busy with that, and I kept doing all my teaching, and during all these years, whereas other people might have given that up, but I kept that on, and the reason was that we had no women teaching almost. So for many students, I was the only female faculty member. I felt very strongly I didn't want to give that up. So I was doing too much at that time.
What classes were you teaching?
Well, solid state physics of various varieties to the engineering students, but by that time I had physics students as well. So we were talking about the center where we're sitting. We're sitting in that.
Yeah.
This place here used to be an ion implantation facility, this room. Mm-hmm. And then after a while, the number of users decreased as this became sort of a standard thing elsewhere. So we made a conference room out of it, which has been greatly used.
You also became associate provost, that's right?
No, I never was.
Okay, my mistake.
That's not right.
Okay.
No, I had, starting with the American Physical Society, then I had many jobs elsewhere. So I became treasurer of the National Academy, yeah, right. Yeah, and so lots of things like that. So.
Did you ever have aspirations for any higher leadership posts within MIT, or did you find the ones outside of MIT suspended?
No, in fact, I always gave the, when I was asked to do various things, because I was asked to do different things, I can't remember all the things, but I didn't want to give up my research program. And so most of the higher administrative positions required strong compromises with how much time you would have for doing research. So I just didn't seek that. And I was busy enough doing service to society and the research community generally with all the stuff I was doing outside of MIT that I was quite saturated.
So your research has covered electron structures and various materials, intercalation, ion implantation, and then novel carbon forms, nanotubes, and now thermoelectricity. Is there a common thread through all of these and an underlying interest?
So it's all kind of, well, we started out with these carbon systems in 1961, and that soon led to nano things, because in early 1970s, when we started working on intercalation, that was a way to look at individual layers, so just at the atomic layer. So I was into nano stuff in the early 70s. And so everything that you mentioned has to do with nano. Thermoelectricity was an idea that for 30 years, from period 1960 to 1990, there was essentially no advance. And the Navy was interested in developing some kind of better thermoelectrics for submarine applications. That was the main thing. And they asked me if I had any ideas, so I said, well, we have all these new materials around now, nano things, that could be interesting. So I looked into it and looked like it would be very interesting. So we had a new field. And that was one field that I started that I stayed with through its development, or much of its development. Now there's so many people working in it, so it's it's hard to, you can't be in every field fully. So the carbon one, as that developed, went to nanostructures, with fullerenes and then nanotubes. We have more things coming down the line probably. So that's a natural for me. So I've stayed with that one all the time. And thermoelectricity I work on also, but to a lesser degree. And then there were other fields that we started that other people have taken over, so that's okay.
What would those be?
You can't do everything. Well, coherent optical phonon generation. I was doing an experiment with Eric Ippon when we discovered that field, and we wrote some seminal papers, but we couldn't get any funding. The time that happened was just right after the Berlin Wall fell, and we were in a kind of a bad situation in funding physical sciences. There was a big recession in funding. So other people followed on with that field. We couldn't get funding. We started the field, but we couldn't get funding to work on it. So it's the way these things happen.
Maybe you could explain in sort of lay terms what the fields broadly that you're interested in are, what intercalation or implantation or any of the kind of nanotubes, any one of the many disparate things you've become involved in. What's your favorite?
Well, they're all nano-related. Okay. So intercalation is the insertion of layers, one layer at a time, of course. So say one layer of a guest species into a host material. So it's nano in the sense you have just one atomic layer, and then you can follow the properties of that layer, how it changes the host and how it changes what gets inserted. Both of them change, obviously, through the interaction. That's interesting. Mm-hmm. So that's one field that we kind of were into at a very early stage, and I stayed with it as that developed and went through its crest and became less, after fields come and they sort of go through some kind of maximum, and then they dissipate a bit. So I was involved with that whole process. But something like the nanotubes, that started, well, really that started a long time ago, because we see nanotubes in high resolution TEM images a long time ago, but didn't pay any attention to them. And then
well, tell me about why your metallic versus semiconducting investigations into nanotubes.
Oh yeah, well that was done. What prefaced that was I gave a talk at a conference and saying it would be really interesting if somebody could think about what properties a nanotube, an individual, just one layer, because that was like intercalation. We had just one layer, but now we have it wrapped up. And the idea was that an object like that could have very interesting properties. So I made a talk about that the structure would be very novel. And then I sort of sketched some interesting projects that we could work on in that field. So this was kind of a talk at a conference. I was invited to talking about nanostructures, because that time it was a fullerene conference that this was. And so you can imagine that a nanotube is built out of making bigger and bigger fullerenes. Okay, that was the way I presented it at the time. And so people seemed really interested in this. I saw different people scribbling lots of stuff down. So I said, gee, maybe this is interesting. So I had a visitor who arrived like 1 month after I gave the talk, a person that was doing a sabbatical here from Japan. I said, well, why don't we work on this and see what the properties really are instead of giving it to everybody else. Let's do it ourselves. So then a second Japanese guy on the same fellowship, but from a different place, and they didn't know each other, came by wanting to talk to me about projects that I thought were interesting. So I suggested it to him too. And I said, well, maybe the two of you might enjoy working on this together. So that was the beginning of, that's how this thing was born.
What's come of it?
Well, lo and behold, about, I don't know, a half a year after we published our paper, making the prediction that these kinds of tubes would be especially interesting because unique properties that they had, somebody figured out, two groups, IBM and NEC, figured out how to actually make these nanotubes. And, but it took 6 years between the time that they were discovered and the experiments were done to show that our predictions were correct. And part of the reason is when you have a new kind of material, it's hard to control it and hard to make it reproducibly. The amounts of material available was so tiny that the appropriate experiments couldn't be done right away. So it took a little while. And there was also a non-believing community out there. You know, the communities, the research communities are always very conservative. They like to believe what has happened before is correct. And when you come up with something that's revolutionary, new, they don't like this. So until the day we published the paper, there was mostly unbelievers about it. And then, of course, when you have the smoking gun, then it's all over. And after that, there's no non-believers. It was total conversion. Yeah.
Now, you've seen many fads within the material science, applied physics come and go. You know, there's the hot talk of high temperature superconductors, and you know, well, it's just around the. There was always going to be just around the corner. Now we talk about nanotubes are going to change everything, and whether or not that plays out is yet to be determined. And I wonder if you had any thoughts about what role the hype has in securing research funds to ensure basic research versus promoting false sort of hope about it.
Yeah. Well, hype is bad because hype builds up false expectations, and then eventually you're caught because if you hype something, it's never going to be quite as good. So you have to, I think, be pretty honest about what the time scales are going to be. And I think that we have to be very careful because, well, we were burned by this high temperature superconductors. I think at the time that they came out, people really believed that this would be pretty easy, because you know that the one thing about high-T superconductivity that was interesting is that the recipe that was given, anybody that tried it within a few weeks could reproduce it. So it wasn't so elusive. Most other things that are in the condensed matter realm are difficult to reproduce, especially if they're not correct. So it takes a long time, and then people keep, well, like this Schern thing that we had about conducting polymers, and that kind of killed the field, because that's worse than hype. That's false results, false data. But even hype is detrimental, because it builds up these false expectations, as I was saying. So we should be careful not to do this. I've been involved in a whole bunch of different national studies, and I try to call it the way I see it and not to exaggerate. But I could understand why there was hype in the case of the high TC, because people were so excited about the fact that we had superconductors go up to 23 degrees Kelvin with great effort, and then all of a sudden went up to 40 and then 90 degrees in 6 weeks. That was unbelievable that something like that could happen, and that everybody could reproduce this. So they thought this field would be easy, a piece of cake. But it turned out it wasn't like that. Control of materials is... The engineering aspects turned out to be a lot harder than anybody ever imagined.
So when it comes
to... And the theory has turned out to be a lot harder.
Sure. So when it comes to these sort of basic science concepts, whether it's high temperature superconducting or fusion, or these ideas that are very much rooted in basic science and then trying to apply them into realizable technologies for society, they always somehow end up being disappointing, whether or not they don't deliver on the right time scale, or they don't kind of realize the gains.
Well, there's no delivering on a time scale, right, because research just doesn't work that way. There are breakthroughs. So the breakthroughs, high TC was a breakthrough.
Right.
But then the follow-up part has proved very difficult. There are many interesting things that have come of this on these highly correlated systems that are interesting to a physics aficionado. But you know, people thought there would be industries, gigantic industries flowing from this, because the kind of money that was put into it initially by industrial labs and the government, all governments, not only U.S.
Is it a question of not having enough basic research dollars, not having enough industry interest? Is it just vary based on the various science?
Well, we go into it in a big way, you know, in the beginning with a great enthusiasm, which is fine, and they get lots of things discovered, and then of course it's shown that this is really a hard problem, and a sustained effort is required to make further progress. And lots of people back out at that point, but there are a few that would like to continue, and it's very hard for those people to find funds. So we need some funds for those people. So that's so we go too big and then we go too small. You know, we have this spike and then we undershoot. So that's the part that's high TC will find some kind of place, and there'll be some kind of applications. We have a few now with interference filters, but we need more than that. And I think it will come with time, but who knows? A laser was a little bit like that, but that wasn't hyped up. So people weren't expecting big things. Now we have lots of applications from lasers, but it took a long time before the applications came. NMR is another good example. It took a long time. And that wasn't hyped up. because nobody thought that that would have applications. But high-TC seemed like a natural for it, but the applications haven't flowed easily, and nanotube seems like an obvious one too, but it's more difficult. But I think nanotube applications are coming. There are companies now that are we see the companies forming. And the high-TC companies, well, there's American Superconductor. They've done pretty well, actually, as a company. They've survived. It hasn't become another AT&T, but look what AT&T did. They went up and then they came down. So that's.
Well, with all of you've been awarded so many honorary doctorates and awards at the national level, as well as holding positions in the American Association for Advanced Society, or APS. Is there something you feel like you haven't accomplished yet? Do you stay up late on Octobers waiting for a phone call from Stockholm?
No, I don't. As a matter of fact, I feel I've been more than honored for, I don't do science to get honors. And so anything that comes along is a big surprise to me. Every one of them has been a surprise. And I haven't looked for anything. I just, actually, some of them, they give me opportunities, like this last one with L'Oreal, with Women in Science. That was well, it was a little bit not totally unexpected, because people would talk to me about it. And because I knew the other winners, and they would say to me, "How come you don't have this prize?" I said, "Well, I just wasn't awarded the prize." That was my answer every time I was asked that question. But then eventually I was. But the point about that prize it changed me in some ways is that I feel I ought to be doing something about it, because the L'Oreal company. They put a lot of money into advancing women in science and engineering worldwide. And I understand why they do it, because it's good for their business. So I can understand that aspect. But for me, I don't really care about their business, but I care about the principle. And so, and they're always looking for some kind of ideas. So if I can furnish some ideas, then we make a good team. So that award is a little different than some of the others, and where you get the award and that's the end. The award from the Heinz Foundation was another one where I felt that it changed me somewhat in thinking about what the applications of my science could be good for. So sometimes you get an award that has an impact on you. And then all the honorary degrees, that has the following thing happening with it, because all of these different universities consider you all of a sudden an alumnus, and they give you jobs to do. So it's not, it isn't that it's an event that ends with the day of the award with those kinds of activities. So I guess that the awards have one impact on me, making me feel that the work that we do in science has some relation to society. MIT likes that, actually, and they encourage us to do that. So I think I'm in a good environment for this.
I was wondering if you could tell me, you straddle three very distinct silos or areas at MIT. You're on the interface between electrical engineering, physics, and material science, which are all very well-renowned and notable programs within MIT. And was it hard either coming in or hard now finding a niche, or did you thrive living on these boundaries? Is this sort of interdisciplinarity something that excites you?
Well, it was very easy for me, but between electrical engineering and physics was easy because I was part of the both departments. And well, even before I joined the physics department, I had many graduate students from physics, and I was involved with their things. Even I wasn't a member of their department. Then I became institute professor, so that really straddles everything. But I didn't really need institute professor to straddle these things. You know, when I ran the materials center in the 70s, so that straddled all the departments already. So, and my research is really at the interface. And what's happened over time is that departments have actually grown together. There's a lot more overlap between them. And also the special roles are more distinct. So I would say that the condensed matter physics side of physics is done mostly in the physics department, with some transitions in other department, but almost that's really very heavily focused. The applications are in EE, very strongly focused. And the materials physics is strongly in the materials science department. And what has happened is that the materials science department has become much stronger over the years in materials physics. Certainly a big difference over what it used to be.
We're talking about thriving on the boundaries between the various departments at MIT, and I was going to ask now is what merits or benefits are there and the associated costs with emphasizing interdisciplinarity within the curriculum versus emphasizing developing strong technical roots? You know, should all MIT students, you know, develop, you know, computer science and material science? Should they all have their fingers in all these various aspects, or should they go send the roots deep?
That's our curriculum has a first year that's pretty common for all MIT students, and many common elements, and I think that that's very good. So when you compare our students to students coming from other institutions, our students have a very strong base in all the different things: physics, chemistry, math. They have a computer science requirement, biology requirement. They have a strong grounding in many things, because those elementary, so-called elementary courses aren't all that elementary, you know, compared to what they have at other places. So I think that that's good. Now the second thing is, so that I'm talking about the input. Now let's talk about the product that we're thinking about. If you're thinking about a research career, which is common to many of our students, not all, but a large number, then the big opportunities seem to be at the areas between present disciplines. How do I know this? I have various inputs. I just chaired a national study on condensed matter and materials physics. Every 10 years we have a national study in this. This is, I guess, I was involved with one before the present, and then the present when I was a chair. The one I was involved in was 2 times ago in the 70s. So I missed one. I was doing something else, I guess. But anyhow, in doing that survey, it's evident that many of the exciting areas are newly emerging fields that are between different areas of physics, like condensed matter and atomic physics, Bose-Einstein condensation, those kinds of topics. And that's forming a whole new subfield of physics. That's important. Another subfield that's very prominent is a biophysics subfield. And so doing the study showed these to be areas where very exciting research is just coming to the fore. And so if somebody would ask me where we should hire, so those are areas. And in fact, the department has been doing exactly that. They didn't need the study to tell them, which is very good, that we anticipate some of these things here. The other piece of evidence I have is I've been on this Packard committee for faculty fellowships, a very distinguished program that we have nationally. And for the last few years, last 5 years, the interdisciplinarity has been sort of a common theme. The very best candidates, the brightest stars in our country, are working in these fields. And they just stand out above the other people. So all of these bits of evidence tell me that this is an area that our organization at MIT should emphasize also. But if you're going to be strong in these fields, you need to have some solid foundation as well. So teaching in the disciplines is useful, but then we should promote some interdisciplinary activity as well. And some of that has to come at the expense of some of the disciplinary, because you can't, in a certain number of units that we allow the students, 45 units a semester or whatever, that's a fixed number. The students can only assimilate so much information per unit time. So some of that should go into new areas of new developing areas. Well, we had biochemistry, and we had different things that we could look back. Well, electrical engineering came out of physics 100 years ago, so we can look at that.
But building on this, to what do you attribute the emergence of these biotechnology, nanotechnology, information technology, neurotechnology even, and the decline of the traditional engineering and physical science disciplines? Is this a natural ecology of ideas, or is this something that we as a country, as a university, should be concerned about?
Well, it's a little different than you just said it, I think. I think that in one sense we're bifurcating and we're developing these different fields at the fringe. But there's another thing that's happening, is the fields are also coming together. I mean, just think about mathematics. They used to be bifurcated into more and more fields. But what they find now is it's more and more important to have a knowledge of the entire field, because we don't know which combinations of things are going to be important in the future. So for me, I had good training across all physics fields, subfields. And that turned out to be very, very useful when I was working in the government, heading up the Office of Science, because I was responsible for a very broad area of science. And that went beyond physics. I had biology, chemistry, all these other things, material science. So having a broad knowledge was very, very useful. And so you think about the students who come to MIT. Some of them go into research, but some of them go into business and other walks of life, and they make use of those are the students that really need this breadth, because they make use of the very broad exposure. So yes, we should have depth, but we should have breadth. And I don't see that they're contradictory, because the disciplines themselves show new aspects within the disciplines that wouldn't be appreciated unless you go through this process of breaking down into different pieces and then putting the pieces together. I don't know if that made sense to you.
No, it did.
But that's exactly what's happening in the fields now. Is that they're going into different directions, but they're coming together, both happening at the same time.
So perhaps on that note, MIT, someone said that MIT is full of these scientists and engineers who are also closet artists, that there's this element of, you yourself can relate, because you grew up playing the violin and the viola, and it's something you still enjoy. But what role do the humanities, arts, and social sciences have at an institute of technology? How have your paths intersected with humanists at MIT?
Yeah, okay, that's a good question. And I wanted to preface that by something that MIT did when I first came to MIT, because you asked about some of the early days. The Research Laboratory of Electronics sort of grew out from the radiation lab, you could say. It's somewhat related to that. And they used to have a seminar going, and Jerry Wiesner, who was one of our presidents in the 70s, he was a big he and Walter Rosenblatt, so probably in those interviews that you must have on tape, would go into this in great detail. They had these seminars that cut across all these different fields, and people would go to them and be stimulated. So they had the Morris Halleys and talking about linguistics and so forth, and but that makes a contribution to fields of science as well. It's not unrelated. And this gave people the idea that the liberal arts and being able to appreciate outside of science things and bring that into science or interconnectedness was an important part, because if our students, our graduates, couldn't communicate with the rest of the world, that would be pretty sad. Because science is good when people know what you're doing, and it's not only to other scientists, but you have to communicate more broadly. So, and to do that, you have to appreciate what other people consider important. So, some knowledge of the humanities, I think, is a very good thing, and our students don't, by and large, don't appreciate it as much as they might.
So that's something that...
I see that other places, science students pay more attention to the arts and the humanities than here. But our arts and humanities, somehow, they try to go out of their way, I think, to cater and make some contact with the students that we really have. And I know this more about the music department, because you mentioned my interest in music areas. You know, amateur, practicing amateur. So I do have had, for years, ever since I've come here, they send me students that double major between EE and EECS, and say certain humanities, especially music. And we have a program, you know, in music, people, they get lessons from people from the Boston Symphony and whatever. And they have to somehow manage that, a heavy time commitment, together with the heavy time commitment of MIT undergraduate education. So I get students like that. And the amazing thing is those students tend to be straight fives or very close to it. And I don't know exactly how they do it, but the people in the music department always tell me how great those students are in their music field, but they're also great in electrical engineering. They're just very, very good students. But they're, to me, a big challenge, because how to make a career that combines fields that don't seem connected is not easy. Like when we were talking about the sciences and how they interrelate, we understand that, and there are many good examples of how new science develops from that. But new science developing from the interface between the arts and science is less obvious, and we have fewer connections of that right now.
How has music influenced your research at all? You've done work on phonons, which are... Is there any overlap there?
No overlap. No, okay. Phonons are very high frequency vibrations, so way beyond any audio response. And I think that it's, for me, it's just mostly relaxation and meeting people that are outside my field, and it's sort of like that. In my early career, most of the years I've been at MIT, my music activities was, you know, one day a week I would sort of splurge and do a lot of it. And the rest of the time it was not too much. But more recently, I guess in the last 10 years, after age 60, I think it started when I was treasurer of the National Academy, and I would spend quite a bit of time in Washington. So I felt when I was home I should have some more music at home. So I think that was part of the the change in my emphasis.
Now, during your lengthy tenure here at MIT, you've served under many presidents, and you served during a period of time which Walter Roosevelt called Camelot at MIT. He defines it as a period between 1966 and 1990 when we had President Johnson and President Wiesner and President Gray all serve in succession, and they came from very similar backgrounds and were closely connected within the each other's administrations. And they persisted at MIT after they had served as president as well. And I was wondering if you could comment at all on the kind of similarities or differences in their styles or philosophies or the ambition you saw for the Institute.
Oh, well, they were just so, yes, they had very much similarities, and yet they had very many differences, you know that. During the Johnson administration, we had turmoil. That was the time of Vietnam, and students worldwide were kind of up in arms against traditions and what we were doing in the present. And so his administration focused on that. And then after that, when Jerry Wiesner took over, that was pretty much finished. And we were in an era where a visionary, Jerry Wiesner was a visionary, and he expanded the operation of MIT way beyond anything that we had ever dreamt before. So we had the center, innovation center, you know, what would we call it? The Wiesner Center.
Media Lab?
Media Lab, yeah, yeah. The Media Lab, I mean, his idea was, that was a kind of a science and society type thing. And, but that wasn't all. It went into many, many areas that were beyond what people had in their own minds. So when we were here, I thought, gee, you know, we're really going well beyond what we ever thought about before. You know, I'd say about women and minorities, he did that as well. And that was one that I understood, so that was easy for me. But the Media Lab was a little bit less easy, and some of the other expansions. But I think that was, we look back at that administration, we needed the time of Paul Gray, who was a consolidator. He didn't start so many new things, or maybe he did, but it seemed that he kind of consolidated many of the disparate things that we had going in all different directions that were maybe not coordinated so well. And when he left, I thought the MIT was working pretty well. We would have had Phil Sharp next. He was been another one of ours, right? He had been a professor here for a long time, and that wasn't to be. But it almost happened. What Chuck Vest did, since he wasn't an MIT person, he had to find his niche. And so he was bringing something to MIT that he thought we needed, that we sort of had. And this was the internationalism. And he extended us into a U.S. science policy in a very big way. We kind of had that with Jerry Wiesner. He just didn't make much of it. But we sort of had that, and we had John Deutsch here, and he did that sort of thing. We were doing it, but less efficiently and less organized. And but Chuck Vest had, I think, a big impact on that. I think in a positive way. I think most faculty would like to see more of that continued. I think we flourished under Chuck Vest. And now we have new administration, and you know, I don't know. It's too soon for me to be able to evaluate exactly what we're doing. What we're doing that's different than any time before is we're organized in some official new university-wide challenges like energy and the environment, and we have to see how that goes, whether we can have an impact in the field. And whether organization of activities from the top, which is kind of the way this thing will work out, as well as in the past the organization have been more bottoms-up type things. And we certainly need to be in the areas that new President Hockfield is finding for us. But
well, you mentioned the MIT's prominence on the national, international stage, that it's been prominent in setting national science and educational policy. But how should MIT balance its obligations as a world-class university with national priorities, whether it comes to setting these sort of national policies?
Yeah, well, I think that we should have a large role in that, because that's a natural for us to do, because we've been doing it well, we're looked upon for doing it, and I think that's brought us international prominence, and I think has been a source for attracting the very best students. Everybody knows about us every place we go. Mm-hmm. And I think that that's a good thing for the Institute.
But given an increasingly international student body and...
Well, we're not, I wouldn't say that we're internationally increasing. I think that with 9/11 we're not probably increasing. I think that we're probably maintaining pretty much. You know, the Europeans are now, they're emulating what we're doing. And they have... 10 years ago, they didn't have many foreign or certainly Asian graduate students in the European universities. You didn't see them. And now they have some. So we've had an influence on them. But in some sense, though, we've lost some of our own, because they're going, we could attract anybody we wanted before. Now it's a little bit, we have more competition.
Are there things we could be doing differently in terms of?
Well, I think lots of that is beyond our control, because it's what's happened in the federal government. I mean, we have all these restrictions. We know that because our graduate students, they're not as free from other countries, they're not as free to travel now and do things with collaborators as they once were before, because they're held up, so they can't get back to the U.S. easily.
Sure.
Even though we try to, make all plans for them to be able to come and go easily, it doesn't work out perfectly.
Let's rewind the tape a little bit and go back to the late 60s. When did you start seeing sentiment among students, as well as the faculty, change in terms of even just changes in how they dressed or their hairstyles, to like the number of protests that were on campus, and just the social movements, whether it was civil rights or women's rights or environment or anti-war? There were so many things going on at that time. When did you start to see these things really take root in the 60s leading up to the spring of 1969? Or
yeah, well, that was a kind of a worldwide thing. It wasn't an MIT thing. I would say that at MIT it was pretty tame compared to what it was in general, because some places they just disbanded education. It got so unruly it was hard to keep classes organized. But here, students went to class, they protested, but they did their studies. I was teaching them at the time, so I can vouch for that. Maybe they weren't as attentive in some classes that they were less interested in. I noticed that, because they had to find time to do these social activities, and that's where it came from. But later on, these people that were involved in all of these kinds of protest movements, they became quite tame, because some of them I met in later life, and they were a different kind of people. They were just like people that didn't participate in those movements. So was it good for the country? Yeah, I think it's always good to have some motion and activity. It's not...
Were you at all sympathetic? Did you become involved in any of the protests or the walkouts or anything like that?
position of a faculty member is not to take sides, but to be ecumenical and accepting of everybody. So a student that was involved with activities and one wasn't, I treated them the same way. I thought that that's always a fair way to go. If I had to do it again, I would do the same thing. You have to stay outside of these individual things as a faculty member, because if you start taking too many sides, then it's hard for the students to relate to you. That's not your position.
Maybe you can tell me what the atmosphere was like in the spring of 1969 through all and into the 1970, when students there were widespread protest walkouts, they were breaking into the president's office, there were bombs going off at Draper Lab. You know, tell me what was going on.
Well, I think you're describing, yes, all of these things happened, but it wasn't so dramatic as you portrayed it. Okay. Yes, these things happened, but they didn't involve all the students. There were many students that were here doing their regular thing as well. And yes, the president's office was invaded, but compared to other places, it was very tame here. I don't know if you appreciate that. It was amazing. The students had these armbands that they would wear, so you knew what they were involved with. And then they came to class and they did their homework. And it wasn't that different in some ways. Technical courses went on just pretty much like they had always done. And there have been other times, when I think about the war years, young people were in charge of major things. You didn't have to be 50 years old to be in charge of something. You'd be 20 years old was enough to be in charge of major things. And so what I saw happening in the 60s is some of that spirit of young people realizing that they had something to offer and they weren't being heard. So, okay, make some noise. You know, in some ways, we've had revolutions of this sort continuing. You know, the information age, when that came along, young people are better at things, some things in technology, than older people, because things have been changing with time and they grew up with it. And so we see these kind of changes. It's not revolutionary. They're not taking over the president's office, but they still have a leadership role in things, even though their age is young. I don't know if I made myself clear to you, but that we have different revolutions taking place in different eras, and sometimes it's more of a political nature, and other times it has a technology side to it.
Sure. Now, in the early 90s, MIT staked out what were, on an ethical and moral frame, were very justifiable, but would become socially and politically controversial positions, whether it was student life or student financial aid or women in science.
Student financial aid was a big issue that the MIT took a very special and strong position, and they invested quite a bit of money in it too. And they got national prominence. But in the end, that turned out well, and I think everybody has MIT to thank for a more rational approach.
Sure. But whether it was the Women in Science report that came out in the late 90s or the student life
the Women in Science report that came out, there were a whole bunch of Women in Science reports that came out that were grassroots motivated. And in that report, the Women in Science one from the faculty was a grassroots, had a grassroots origin. It wasn't something that came from on high, but it had a grassroots origin that attracted attention by the administration and some level of support. Once they did some investigation themselves, they so it had some merit. But that had a big impact on the whole country, the whole world, in fact, because things have changed elsewhere too. It's not only in the U.S. and it's not only MIT. So, but a lot of it started here, but it was ready to happen.
What was your involvement in the Women in Science report? Or
I was involved with the early side of it when the women first got together before there was any organization. My position about it was that I had led the 1970s organization, you know, when we were trying to recruit women and provide support for them. And so I was very active through the 80s until I was president of the APS. And so I felt that I had done my thing. And I said it was much better for the next generation to take over than to have the old-timers do this. And I still think that that was the right approach, because we have to keep developing talent for each generation. So I was involved in the early stages of it, and I would be called on for different aspects of it now and then, but there were other leaders that took over that were in the age group, appropriate age group of active senior faculty.
Now, you mentioned when you had started at Lincoln Lab in the early...
See, I was, 1990, I was 60 already, right? So I didn't think that that was the right age group to be involved in something like that, in the leadership aspect, just supporting.
Sure. You mentioned when you had started in the early 60s or the mid-60s that being a woman wasn't a handicap because there's such a great need for qualified scientists to do basic research in an exploding job market.
That's correct.
So, but through the years, did you yourself experience discrimination in the overt discrimination, or?
Oh, now and then, but I would say that with time it was less and less incidents with it. And the big change that occurred, and it must have occurred sometime in the mid-'80s, when the men themselves kept coming to me to find ways of getting more women involvement in science. See, before it was up to women to do something, but then it was all of our problems, and that came in the mid-'80s, and I think that that has made a big difference.
What?
It's going to be some time before we have equal numbers of women in the sciences. I don't know whether that will ever be, but as students now in graduate schools or in the undergraduate programs nationwide, there are large numbers of women in undergraduate degrees now.
Certainly within MIT programs at the undergraduate level, like biology or chemical engineering or biological engineering,
right,
women
material science, more women than men.
Right.
Yeah, right.
And there's always this, you know, whether it's from Lawrence Summers up the river and he talks about innate differences, or there's still this sort of underlying.
But look what's happened.
Right.
You know, the reaction was of it. There wouldn't be a woman president of Harvard probably if not for Larry Summers. I mean, I think that the reaction against some of his comments, when somebody interviewed me right after that, I said, I predicted that it would turn out like this. There's some formal comments I think I made to the press, that the outcome would be opposite, because the remarks that he made outraged men. In the past, remarks like that outraged women, but now they outraged men. And that was the turning point for me. So there would be more things happening positively, formal things happening at Harvard for women, and there would be more appointments for women. I saw that coming.
But does that sort of mindset reflect the mindset that was present when you were rising through the ranks, when you were a younger faculty member, or?
Well, you know, I was saying in my early days, we had very few women, and there were just individuals that felt that more equality was a good thing. And most people were kind of nonchalant, not interested. But then what happened is that their daughters started getting interested in careers, and that made all the difference. I think that's what turned it. No, it takes a while for these. It takes at least a generation. And in fact, the progress of women in science has been faster than anything I would have expected. And it's because it's a cooperative effect. Mutual things have happened that have made it happen this way.
We're moving into the home stretch now, and I guess I want to ask some like broadly reflective questions. And I would ask, what about MIT sets it apart? What makes it unique? Why can't other universities imitate its success? Is it something about the administration, the faculty, the student body, the research that it does? What is it that makes it?
It's the whole thing, I think, and also some of the history. We attract some sensational people, and I think that we're willing to take risks in appointments, and I hope we continue to do that, because we don't always know how things are going to turn out. So I believe the faculty really is the thing that drives MIT to begin with, and the students that are attracted because the history and the faculty and the programs and Europe. We have Europe, when it started, was not understood. There was undergraduate research, but to have many students involved with it and have it as the norm rather than the exception was something that took many people by surprise. And I think that Jerry Wiesner was a big factor in promoting this when we had it and giving it some resources so that it could take hold. And then they got grants from interested alumni.
Speaking of Europe, how well did you get to know Margaret McVicker?
Oh, I knew Margaret McVicker really, really well. And Margaret McVicker was a person that had great problems at MIT. And it took her a long time because she was not along the beaten path. And her contributions were not, as a faculty member, were just not straight research, but having ideas far outside the box and implementing them.
Did she come to you at all? Because she's best remembered for being instrumental in getting Europe started or off the ground, at least in some respect. And maybe what involvement did you have with her on that?
I had a lot of involvement with Margaret. She used to come talk to me frequently. We're in similar fields. And we had some common backgrounds because she was a student at Cambridge. Mm. And I also was many years before her. And Margaret just had a lot of problems. She'd like to have somebody to come talk to. So I was a recipient of information sharing. She was an early faculty member. She joined the faculty roughly the same time as I did, much younger than me, but still. And I was a senior person, so I could give her some advice or whatever, discussion, shall we say. Well, I think Europe went far beyond my expectations. Because
the number of students participate in, or the products of it, or?
Yeah, that it would be so successful as an educational tool. And that it would benefit as many students as it did, and that we would figure out a way to accommodate them in the programs and all of this.
It seems that so many MIT students have this basic kind of natural imperative to tinker or hack or just experiment.
Right. Yeah.
Does this tap into that kind of natural reserve?
Yeah, it really does. It really does, and it gives it an organized way to develop with some training. I did something like Europe with my my own children. I brought them to the lab and had them mix with the graduate students. And it was that experience, and so that happened in the early 70s, and it was that experience that helped me to appreciate what Europe could do for even pre-college students. So she was kind of right about it. It is an organized way to develop tinkering. And it's good for the graduate students to have some younger buddy to supervise and push around a little bit. Yeah. Good family type building. So you asked about what makes MIT unique. I think it's experiences like that that make MIT unique. But in some areas, MIT hasn't done as well as it should. Like, for example, organizing a nano program, whereas many other centers, Harvard down the street has a very nicely organized nano program. And we have lots of nano people here, but we're not organized so well as many other places, Northwestern. Mm-hmm. I can think of a whole bunch of places that.
Derek Bakken is, who's a former president of Harvard, mentioned in his 2007 commencement address that looking forward that universities will have to decide which kind of sciences they want to excel in, because the cost of doing both basic and applied research is that the costs are rising so high. So what, you're going to have to decide to pursue a nano track or a bio track or something like that, that universities can no longer afford to just do everything and do it well. Is that a view that you share, or should MIT or other universities still strive to support across the spectrum?
Well, MIT is a university that focuses on science and engineering, so we have to have at least some breadth to our activities, because that's really what we do. But we can't do everything. But we should do the important things, and I guess that sometimes organizing along some themes brings facilities and brings support. Nowadays, well, I look at few places that we've missed out on. That's one of them, I would say. Mm-hmm. We just didn't have a local champion that did it, and Harvard did. I think that they had Venke there, and he played a large role in making that part happen.
Sure. Now, your professional commitments still figure largely in the things that you do, as you're now the president of president or chairwoman of.
I'm chair of the board of American Institute of Physics.
Okay.
Is that what you were referring to?
And
Yeah,
so,
yeah,
and
yeah.
you were previous president.
Yeah. Well, this is my last year with that.
Okay.
I'm finishing my 5-year term.
How do you enjoy that? What are your responsibilities there? What are the projects you're working on?
Well, that's kind of funny. One of the MIT professors is responsible for me doing that. Jerry Friedman, who is another MIT person that I'm sure you've interviewed or should interview in this series. He was chairman of the committee that nominated me. So what I saw is that the different professional societies can do a lot for strengthening the physical sciences, including physics. So when I went into the job, that was what I thought that my role would be. It's sort of like what Chuck Vest was doing, but from the society side of it. And then when I came there, what I found is that we had a revolution taking place in information technology affecting publications, and that was such a crisis situation that required full attention. So you start something with one idea in mind, and then you do something else because you have to survive as an organization. And I think that the pressure on how we disseminate information is still going to be a major initiative and responsibility for the person that takes over from me. We haven't settled even after 5 years, because this happened my first year in office, and even after 5 years, we don't really know where publications are going. To what degree the journals, as we know them now, they're mostly online, they're getting more and more online, but how is this all going to settle, and who's going to pay for it? That's not worked out, and until that gets figured out, these jobs are going to be very challenging.
If you saw yourself 25, 30, 50 years ago, and based upon all the experience you've had since, and what you see...
I never would have dreamt I would have done any of this. So it's all been a big surprise to me. And I take each new opportunity with enthusiasm. I enjoy all this, but I really enjoy doing science, and I'm still doing that. So that's my main thing, and I do these other things a little bit on the side.
What advice would you offer to young and upcoming physicists or other scientists who are longing to do research, or academics, or other young women who are looking to get into science?
It's a wonderful career. It's such a great career. I couldn't think of a better career. Now, it maybe doesn't pay as much as some things, but the other rewards are so fantastic that I really have enjoyed working with the students and all. I've had a large number of graduate students I work with, and postdocs. That's been terrific. I really enjoyed that. I mean, more than anything, that's what I enjoy. I still enjoy it now. And all these other activities that are visible when you look at my CV, I enjoy doing them too, but that's a secondary thing. And it's a lot of it I do is service, and in part, I've said this to many people, but we haven't touched upon this in this interview, that when I started out my career, I thought I had no career. And the fact that I have had a career is because of society. So I feel that I should pay back for that. So I do all of these things for the profession and people not in the profession, outside the profession, because I think it's the right thing to do. And I've gotten personal satisfaction from doing it. And the job at MIT allows you to do it, and MIT supports you for doing. It's not a negative in your career here. It's a positive when you do good things for society. Of course, if you don't do good things for science, it's not good. You know, your primary evaluation, I guess, must be in the science that you do, and the teaching, and the students, and that's always been my primary consideration. But this time and possibility to do these other things as well, when they come along, I don't look for them. Sure. It's not my goal to look for them, but they pop along and I try to fit them in.
Maybe you described that some of the rewards of being at MIT as a faculty member. Are there particular events, moments in time that were particularly rewarding or affirming or vindicating, or is there traditions that you participate in over and over that kind of reaffirm your belief in the decisions you made or the choices you made?
Yeah, well,
whether it's defending a thesis or a hooding ceremony, or...
Well, thesis exams are not all of them are of a elevate your intellectual level, but about half of them do. And people really discover new things that are very exciting and sometimes surprising. So I don't exactly know how this works, but I think the students select the people on their committee to some degree, and I have quite a wide spectrum of thesis committees that I'm on, and there's so many very exciting theses that I consider that a plus in my experience here at MIT. Of course, I think my own students, I really like what they come up with for the most part, but you know, I've had some role in that. And speaking of students, I have made it a policy to take on always a couple of students who aren't making it and try to make something of them. I've succeeded in most cases. I think that's a role that we should all participate in to the degree we can, because every person that shows up has some talents, and we should try to bring them out. Sometimes it's hard to find exactly where the talent areas are, but we should work on that. So I do those challenges as well. And some of that is hard work and not always as rewarding on the surface, but sometimes with an undergraduates that I've done that kind of work with. Some years later, 5, 10 years later, I get a note from them, and I remember how hard it was working with them when they were here. But I really am very pleased to see what they've made of themselves, and they come back and thank me for what I did for them. I like that.
Is it a matter of directing or having them find their own direction, or providing support,
well, it's no, usually making a lot of suggestions that keep them from quitting, and giving them some ideas about how to set priorities, how to organize your time, and how to cope with difficulties that they encounter and so forth. And research is something similar to this. So,
all right. Well,
yeah.
Last question.
Those are some of the issues that you didn't raise, but it's not only the great students we all enjoy. That's obvious, you know that, and we have so many of these brilliant people here, and it's really great working with them. That's a great attraction of being at a university like this, is the number of people like that you get a chance to work with. And faculty also, young faculty. Working with them is a great privilege.
What would you say MIT's trajectory is? What is it evolving into? And if you could change its direction, how would you change its direction?
Well, how is it evolving? I think one of the things that I see happening now, it's getting more international. They have associations with a lot of different countries and different programs, and maybe they're good. I haven't had much involvement with those formal programs because I have my own independent. I think many of the senior faculty, we have international collaborations that go back many years, and we're always accepting students and going and sending students, accepting students, and that's been a great resource for the development of the individuals. Having formal programs might be good. It remains to be seen, but I think the MIT shouldn't stretch itself too far, and we shouldn't have these formal programs take the place of the individual one-on-one relations, which produce great research, because for me, these interactions with people in other countries, nowadays with internet and whatnot, you can work with them as if they were around the corner. So, of course, visiting them once a year is important, so, because there's nothing like a face-to-face now and then. But I think we should pay attention to leaving time for people to have time to do those kinds of things. And we'll see how the formal, what the outcome of the formal ones might be. I'm not sure how they're going to work out, but they shouldn't take too much of our resources, our intellectual resources.
Maybe you could tell me a little bit of Rosalind Yallow, to go all the way back to the beginning. Maybe if you become...
I actually haven't seen Rosalind Yallow for the last couple of years. I wrote a short biography of her for a book, and she's had a lot of health problems, and I don't know to what degree. I suppose she likes to have some intervention, but I mean that she would like that I spend time writing to her. Or, I don't know about calling her, but I think communication would be through writing mostly nowadays.
But the way that she influenced and encouraged you, do you try to replicate that with your students? Was she a role model in that sense?
Oh yeah, of course, yeah. Well, she had a big influence on me when I was growing up, and what was so good about her is her giving to young people like myself when she was going herself through all kinds of difficulties, because it wasn't easy for her to establish her career. And the time she was interacting with me was the time that she was just beginning, even before, at the threshold of her starting. And then in the subsequent years, when she was always there for advice or whatever, she popped out of the background. I never even asked for anything. She would always be there. And it was amazing that she did all of these things. But I used her as a role model for this. But another person I used as a role model was Enrico Fermi. Because he was also, my interactions with him were of that nature. And everybody that I knew that knew him had a similar experience with him. So he died much too young and would have had a lot more influence on more people. But he certainly, in the short time that he lived, he influenced science and science education. So.
How well did you get to know Fermi? He was famous for his modesty?
No, I knew him very well. I think that because the number of students, the student-faculty ratio was like kind of 1-to-1 in those days. You know, there were not so many students, and there were quite a few faculty. And he was a great teacher, and I had him for class right first thing in the morning, and on my way to walking to school, I would see him, and he would cross the street and walk with me. Who else would do anything like that? You know, that's, you know, just being very friendly, and that was had made a long-term impression on me. The other thing that influenced me very strongly was his ability to work in every field of physics at one time or another in his career, often simultaneously. And the breadth of his, in one person, being able to do forefront research in so many areas was astounding. And I think that was another strong influence on me and most anybody else that he intersected. And we have a number of people here that know him also on the faculty at MIT. I don't know how many of them you've interviewed so far.
Well, I think we're just about out of time. We ran a little over.
Can I ask one quick
question?
Given your unique
role
here at MIT, you know, when you came here and worked with your husband, and you raised your family. Do you consider MIT part of your extended family?
Oh yeah, oh yeah, absolutely, absolutely. MIT has always been my extended family, and my students are like my children, and we keep in touch with so many of them. You know, when something happens in their lives, they let me know, and yeah, it very much. It's not only my research students, but I'm always meeting students that have had me in a class, and they remember me, and they pop out of nowhere, and I can't remember them all because, you know, when you have a bunch of people in the class, you can't remember all the faces, and then after time they look different. But they come around, and they're recounting the same things that I said about people that influence me. They doing it back to me. I have changed roles over what we went through in this interview. Yeah, but I think that from my own mentors or people that influence me, they help me to keep up the tradition. I would say that among women students, I've had more of that effect than on students generally, because especially in the early days, and even for the men, I would be the only female faculty member that they would see in their entire taking courses here. That happened to many, many students. So they remember me because of that.
Kind of like a den mother or
yeah.
a surrogate of some
yeah.
sort.
You know, the Swedes once gave me a name on TV, a Queen of Carbon. So, you know, I have a certain position, like in the field of carbon nanostructures. I'm the person that at the end of the conference they call on. What did we learn at this conference? I give the summary talk. What did we learn? You know, you get certain roles that happen as a function of time, you know, and you do them a few times and they get used to you. They want you to keep doing that. So, yeah.
For you, it's been a real family experience here.
It's not only that MIT has been a family experience, but my professional life has been a family experience because I don't only have this relation between the people that are here, but the people that are elsewhere. And I felt this particularly when I was serving in the government, and they would send me out for missions, so to speak, different countries. And any place I went, there were people that had me for a class or whatever, any country you could name. And so I had my entourage already there. And, well, the Department of Energy would make some arrangements for me to do this or do that. But my own informal group of people were much stronger. They could do much more for me to make my visit a success than anything that the Department of Energy could set up. And it wasn't the fault of the Department of Energy, but it was the benefit of science. That science is a universal language, and we know each other, and they care about people. So, you know, now we're not so much loved in foreign countries, at least in a diplomatic sense. When you go, you hear about that. But on a personal level, it hasn't changed. So that's it. And MIT should benefit from that, because MIT is all about science and engineering and about this international win-win situation, because we've done so much for careers of many people everywhere, and they appreciate that. So when we go to these places, they start with a positive note, not a negative note.
Sure. One last question. Do you have a favorite hack favorite prank that was played here at MIT? Does one come to mind particularly?
Well,
being
you know,
clever?
I sit out and you look out up there. So I look out at the tower over 77 Mass Avenue. So when they put the cars or whatever pranks that go up on the dome, main dome, I see them, and I see them when they undo them. So when they have the times that they put automobiles up there, I don't know how they do it, because they have a hard time taking them down. But those are the pranks that I actually see, and they're so funny and so surprising. They cause a little trouble, but I think that we're willing to put up with that.
Just out of space here.
All right.
Thank you.
Thank you.